Morning, class reps, please show your hand.
Okay, good morning, everyone. Yeah, we are continuing the lecture. I think we are about 128. Today, many people can join the Zoom. And maybe I think about 300 can join the Zoom, and then the rest, those who are not able to join the YouTube. So I think we'll just give them 2 minutes and start. We are 124. Let me check the Zoom, how many we are there. Hey, okay, I think we have about 13 here. Hey, is it 13? No. Yeah, 13. 13 there. So, yeah, so many of you to join the Zoom because that one you can take more. So I give it them 2 minutes to join. They will continue from where we stopped yesterday. And just a revision. Yesterday we tried looking at the introduction to neuroanatomy. So we look at the components of the nervous system, where we say the nervous system is made up of three main components, and we're supposed to write them down. We have the input or the sensory component that carries information from the periphery, like the external body, external environment, and the internal environment to the brain and spinal cord. And that one is the central nervous system that has the power to interpret and integrate the information that is brought from the sensory component. And then a judgment or decision is made. So that is the executive part of the nervous system. They take decision, and this decision is carried out by the third component, which is the motor or with the afferent fibers carry these information to the periphery. We have three main function of the nervous system. So say the one that controls our behavior, the way we walk, the way we talk, the way we eat, our feeling, okay, whatever it is that we do, any activity, It is the nervous system that controls that. The nervous system also control all physiological processes in our system, our body. And these are very important. For instance, your body temperature is 39, 40 degrees Celsius. This will be brought back to normal by a process called homeostasis. And the nervous system play a role in that. Okay. So okay. So let me see whether I can do recording. All right. So that is the so we talk about the behavior, nervous system control our behavior, nervous system also bring about the physiological changes, and then nervous system enable to retain the information and retrieve this information from our brain, so that whatever I'm teaching, I taught yesterday, is supposed to still be there. At least one thing should be there, not everything. After lectures, about 50% of things decay within 24 hours. So I don't expect that you know everything, but about 50% of what I taught should be in your brain, should be retained. And that is the function of the brain, memory. We memorize. And then experiences in the environment are memorized. And that makes it human being. If you go somewhere there's danger, that thing should be in your mind. If I told you something, it should be in your mind. So that is in your brain. You retain it and use it in future. Good. So also look at the type of cells that nervous system is made out of. We still have two types of cells. And this includes the neuron, which is the basic functional and structural unit of the nervous system. And the neuron structurally is made out of the cell body and processes. And the processes are dendrites and axons. We say dendrite conduct impulses toward the cell body, while the axon conduct impulses away from the cell body. Okay, so we looked at all the functions of the neuron, and then we said neurons structurally can be classified into three. We have the multipolar, bipolar, and unipolar neurons. We looked at that. They can also be classified functionally into the sensory. Sensory is also known as afferent. They carry information to the brain. And then the motor or efferent. They carry information from the brain to the periphery. And then we have the interneurons, which can be association neurons within the central nervous system. We also look at the 6 types of neuroglia. That is the cells that are supporting the neuron to function. And you have 6 types of them. 4 of them are in the central nervous system. And these include the oligodendrocytes. So we have the oligodendrocytes, we have the astrocytes, epidermal cells, and microglia. These are 4 in the central nervous system. Oligodendrocytes myelinate the axons. Okay, and this myelination helps in the speeding up the impulse action potential on the neuron. Okay, then we also talk about the 2 that are in the peripheral nervous system. And these include the Schwann cell, which perform the same function as the oligodendrocyte, but this time in the peripheral nervous system. Then we have the satellite cells. or gangliononucleoside, which surround the ganglion in the peripheral nervous system. And we say a ganglion is collection of cell bodies in the peripheral nervous system. And collection of cell bodies in the central nervous system is referred to as that one is referred to as nuclei or nucleus. We also talk about the bundle of axons. And we say bundle of axons in the peripheral nervous system is referred to as the nerve. So they ask you what is a nerve? It's a bundle of axons in the peripheral nervous system. And bundle of axons in the central nervous system referred to as a tract. We talked about that. And then we went into, looked at the brain. So that is the central nervous system, which is made out of the brain and the spinal cord. And the brain is in turn made out of three main parts. So we are now coming to look at the brain in detail. Okay. So, like we said yesterday, so I believe you can see, yep, we also talk about the coverings of the brain, starting from the skull, the meninges, the meninges, and then there is also a fluid-filled cavity, that is cerebrospinal fluid. The excess secretion of cerebrospinal fluid or accumulation of cerebrospinal fluid is referred to as hydrocephalus, which could be communicating or non-communicating hydrocephalus, depending on the cause. So we'll continue to look at the brain now in detail. This is the brain here. And like we said yesterday, the brain is made up of three main parts. So, yeah. So the brain is made up of three main parts. So from the diagram, we are just looking at the lateral aspect of the brain. So the whole of this one, I'm going to circle that. So the whole of here, going here, here. This is what we call the cerebrum. If you remember, I drew some diagrams. The cerebrum, that is the largest part of the brain. Then, if I take this, the one down here, this is the cerebellum. So it makes out three parts. So this part is cerebellum. And then the small part here, coming all the way down, coming this way, is what we call the brain stem. So these are the three major divisions of the brain. So we have the cerebrum, okay, we have the cerebellum, and then we have the brain stem. And we say the brain stem is made out of three parts, which we will be looking at. So let's look at the first part, which is the cerebrum. The cerebrum is the largest part of the brain division. It's made out of two hemispheres, two cerebral hemispheres. So please, can you be writing down? So it's made out of two cerebral hemispheres. So you have the left and the right. And these cerebral hemispheres are joined together. So this is half of it. This is half of it. That is, so this one is the right cerebral hemisphere. And these are joined together with this at this level, this structure. And this one is called corpus callosum here. If you look at it, that's what I'm underlining. So that's the corpus callosum. And that's the one that connects the right cerebral hemisphere to the left cerebral hemisphere. So there's a deep groove or fissure between them, between the right and the left. And that is the longitudinal cerebral fissure. Okay, so the two are connected by the corpus So your right side of the brain and the left side are connected by this structure called the corpus callosum. So now let's go back. This is, you can see that the surfaces of the brain is not smooth like things that are smooth. It's rough. It's thrown into folds. You can see the folds. This is a fold. These are all folds. So your brain should not just be very smooth. It should be rough. It should be folded. The fold or the elevation like this. This is an elevation. This is an elevation. These elevations are referred to as jara. Okay, so let me write it here. So jara or jaros or singular. Okay, so jaros. Yeah. Jaros is singular or jara like this. Okay, so the elevations on the surface of the brain, okay, elevations of the surface of the brain are called jara, a singular jaros. So you can see there are depressions between the jara. You see this depression there. The depressions here. The depressions are referred to as sulci or singular sulcus. Okay. Now we use all these jari or elevations. They have been named. Okay, they have been named, but we will just use three of these jari. Okay, somebody say, "What? Can you please increase your volume? Can you also increase your volume? Check your, because I'm talking very loud. Okay, so try to increase your volume to and see. Okay, so but I'll increase more. So I'm saying that the brain surface is not smooth; it's thrown into folds, and these folds are referred to as jara, and the depressions are called a sulci, which are written jara and jaros. So sulcus. Let me write that one too. So this is sulcus and that. That is for singular. Okay. Then I was then saying that we use three of these sulci to divide the brain into lobes, like each cerebral hemisphere. I told you they have right and left cerebral hemisphere. So each of them is divided into 5 lobes. Okay, each of them is divided into 5 lobes. And the demarcations are 3, three sulci that we use to divide that. Now, this is one of the sulcus that we use. This one here, let me draw it more. So this is sulcus, and this one is called lateral sulcus. You can see it here written there, those who are watching. Yes. So lateral sulcus is one of the important sulci we use in dividing the brain. Then we have another one here. This one going that go up all the way, continue here. So this one, so that's another sulcus, and this one is called central sulcus. You can see it up here, central sulcus. Good, I've underlined it. Or let me circle it so that you see. So central sulcus, and then we have lateral sulcus. These are 3 1. Please write them down because they are very important ones. Okay. Then we have another one that is really, if you don't look at it at the inner part, we don't really see it well. But it's also run this way, coming down this way. Good. Okay, so here this one will join it a bit. Okay, it's run and join like this. Good. So you can now see that this cerebral hemisphere is divided into 4, like looking at it on on the surface, we are seeing 4 because from this central sulcus, this is the anterior part of the front. So this may call the front. This one will be called the frontal lobe because it's under the frontal bone. So this one is called frontal lobe. Okay. Then this from the central sulcus to, okay, I didn't mention this. So this one is called the parieto-occipital sulcus. Like parieto-occipital sulcus. So write down the 3. I'm repeating them. Yes, I'm repeating them. So we have central sulcus, this one. We have lateral sulcus. And then last, we have parieto-occipital sulcus. So write these 3 down. So when I ask you to list the 3 main sulci that are used in dividing the brain into lobes, we should be able to list them. And we'll be writing our the IA online. Maybe you get me time on either Thursday or Friday. Yeah, tomorrow or Friday. Yeah, so that we'll write an online IA on that. Good. So all right. So I'm going to, somebody said to repeat. So what I'm saying is, we divide each of the cerebra, the right cerebral hemisphere, the left cerebral hemisphere, into lobes. It's not so. These lobes have functional importance. The 3 sulci that we use in dividing the brain, or that indicate the division or the demarcation of these lobes, are the central sulcus, lateral sulcus, and parieto-occipital sulcus. And so now the brain is divided, the cerebral hemisphere is divided into the 4 out, like when you look at it here, 4. This one is called frontal. So frontal, that was to put F there. This one is called parietal. You can see P. This one is called temporal lobe, and this one is called occipital lobe. So here, occipital lobe. So if you look at the picture at the top right corner, you see different colors. So this frontal lobe, you see I have the label. This is parietal lobe. This is occipital lobe, and then we have the temporal lobe. Okay. So if you let's go this way, and that is if you divide it, and we're looking at the medial surface of the brain. We were looking at the outer, like the superolateral surface of the brain. Now we are looking at the inner part of it. Okay, we're looking at the inner part of it. Okay. And so okay, so this is the medial surface. You can see that we already learned this one, that this one is called a corpus callosum. And so this one too is a very likely question, that when they add the structure that connects the right and left cerebral hemisphere is called, and very likely question, the structure. So we should keep in mind of that. Now, so if you look at this, I want to show you this sulcus. I'm using a red line here. This one is a parieto-occipital. So when you go to the lateral aspect, we were drawing, that place is not all that clear, but I was able to put something there. So this one is called parieto. So you see the name there, parieto-occipital sulcus. Parieto-occipital sulcus. That is there. Okay, parieto-occipital sulcus. So that's part of those 3. Now there are other sulci which I may not bother you much with them, but there's one particular sulcus that I want you to learn. This one in the frontal, in the occipital lobe. Remember the cerebellum is in the occipital part, so this is the cerebellum. Okay, so we are not talking about that one. This one, this sulcus. Oh, I'm trying to draw it here. This one, I'm drawing there. This one is called calcarine sulcus. It's here. Calcarine sulcus. Now, calcarine sulcus is very important. We'll talk about that because that is where you have the visual center in the occipital lobe located. The visual center, whatever you are seeing, okay, is located within there. Okay, so let's go back to this one. Now we are going to look at the function of each of the lobes, and that's also very important. So that if you are a nurse, a midwife, or public health nurse, you have a patient, managing patient with stroke, managing patient with neurological conditions, you should be able to tell which part of the brain the person is having the lesion, that there is injury on that part. Okay, so let's take the frontal lobe first. So we'll write them down. You should write them down. Have a pen and write them down. The frontal lobe, we'll learn one gyrus. That is very important. You know, gyri are the elevation. So this is the gyrus. From so if I this is another sulcus which I will not be bothering you to know. So between this sulcus, pre-central sulcus, and then this one is a gyrus. The gyrus is called pre-central gyrus. Look at it here. Pre-central gyrus is is part of the frontal lobe. This pre-central gyrus is the one that controls all motor activity, like all movement. So let's put it that it is the primary motor cortex. So let's write that down. The function of the frontal lobe. So we say we have a pre-central gyrus in the frontal lobe, and it is the primary motor cortex. That is the one that performs all the initiation of all voluntary movement. If I want to raise my arm, my hand, it will come from that place. The decision will be taken from that place. I want to dance, I want to run, I want to do this. And information get there, get to the muscle that are responsible for that particular movement. So very important. Very important. Yes, Matt, your hand is up. Let me see. I have to. Where is Matt? So,
sir, please come again.
as you come again.
Yes.
Okay, the hand tweet up. It's him. Hey, is it? Where is he? Or the hand has come down again. Okay, so Smart. What I'm saying is that we're saying that these loops have functional importance. Okay, the frontal lobe, number one function is that it's the one that is responsible for all movement. If I want to raise my hand, I want to raise my leg, I want to move my head, the impulse will be initiated from the precentral gyrus. The precentral gyrus, which is responsible for what? Primary motor activity. So that is primary motor cortex. That is what I'm saying. And let me look at those. Some people say that we are 10 to 1 people. Please, can you join? You can even join those are the YouTube. You can join there because it's not full. We are just 221 there. You are 10 to 1 there. You can join the other one. There's Zoom. Okay. There's no space. So what I'm saying that the frontal lobe is responsible for one, primary motor activity. So it had a primary motor cortex responsible for all movement that you can think of. So now let's look at clinically what happens. If somebody have hemiplegia, Like paralysis, one side paralysis, people are working the wall, so you know what I'm talking about. You have stroke, and the person cannot move the limb, you can't move the lower limb, upper limb, or the one side is paralyzed. It means that now this cerebral hemisphere, so we have the right side and the left side. The right side control the movement, so the right primary precentral gyrus control the activities of the left side of the body. The fibers cross over, while the left side of the brain control the activities of the right part of the body. So there is that crossing over. So if somebody have right-sided paralysis, hemiplegia, it means that there is injury to this side, to the precentral gyrus, which is responsible for the movement of the body. Okay, is responsible for the movement. And now that there is injury here, the person cannot. So when you say raise your limb, the person cannot raise it because this part of the brain is injured and cannot take that decision to move it up. Very good. So that is one good thing there. Then also, so on the frontal lobe, let's write down another thing. There are a lot of things. When you come to this part, I'm going to say
Okay, guys, so I think he's off. We'll get him back soon. Thank you. Mook, Mook. Hello, Mook.
Hello.
Hello, Mook. Mook. Abigail. Abigail. Hello.
Yeah, Jay.
Yeah, please. He's saying he has joined, and so I should give him the host. But then looking through the people, he's not here. I'm sure probably he joined somewhere else. So kindly call him, and then that's a phone for next and a half. Hello, sir. Hello, sir. Sir, please, I've made you the host. I've made you the host now.
Okay, so sorry, the network is very unstable. Very unstable. That is unfortunate. That is that lapsed, but thank God it had come again. I'm still using a different. I'm using my own hotspot to see because the university one had just cut off all that. So let's try with this again and see what happens. I'm trying to, if because people are always making noise. That's why the thing has been forced to mute everybody, and you can't really talk. If you want to talk, you raise your hand, I will unmute you, and then you can ask a question on that. Yeah. So we're looking at the looks. That is the looks of each of the cerebral hemispheres. So we mentioned 4 at the moment. That we have the frontal lobe here, we have parietal lobe, occipital lobe, and temporal lobe. Now we'll add another one, making the 5. But we went on to look at the function of each of these lobes. Okay, and these are very important. Okay, somebody reminding me of recording. All right. Yes. So we're looking at the function of these lobes. So when we started with the frontal lobe, and we're asked to write down that this part of the brain, which is called the precentral gyrus, is for primary motor cortex or motor activities, movement, any movement you want to initiate. Then we're here where the circle, I circle here, and this part is the prefrontal cortex, and is for the personality of the individual. And personality, we are talking about your behavior, the way you laugh, the way you talk, the food you eat, and how you behave. That is the part that is controlling that. Okay, I think most of you have done psychiatry, so you've heard of mental illnesses, let's say schizophrenia, mania, depression, and whatever. It means that this portion of the brain is the part that is defective. Okay, your thinking, your the way you think. Okay, that the part that when you are thinking, your judgment, your reasoning, all is packed here. Okay, so it means that if there's injury here, there's problem here, your judgment would not be like what the society believes you should be, like the way you dress, or you are even naked. You don't feel that you are naked. You are not feeling shy again. You don't bath. All will be destroyed. That is the part. So it's part of the frontal lobe. So when you are thinking, so write it down. So the way you think, or it's personality, but personality involves your thinking, reasoning, judgment, decision making, and whatever. They are your personality. Okay, so that is the part of the brain that is doing that. Then third part, we'll come to this portion. This portion, like here, I'm circling here. This portion in the also still in the frontal lobe is our language motor, our language center. Okay, language center. So for me to be able to talk, okay, my larynx, my tongue, my lips are moving. It is this part of the brain that is making me to talk. And usually in the left cerebral hemisphere, for the right-handed people, the language center is here. Okay. And those who are left-handed people, the language center is in the right cerebral hemisphere. So I'll take that again. I'm saying that we have the language center in the left cerebral hemisphere for right-handed people. If you hand your left hand to your right hand to write, right-handed. So your language center or the motor language center or broadcast is here. It's in the left cerebral hemisphere. But if you are a left-handed person, then the language center will be in the right. Okay, it will be in the right side. Beatrice, I'm asking you to unmute. Yep. Beatrice, you can talk.
Hello, sir.
Yes.
Sir, can you go over to personality again?
Which one? The personality.
Yes, please.
Okay. So I'm saying that, okay,
Okay.
there is also a Gaza or Gaza. I don't know what is the Gaza Street. You can talk.
Sir, so what about those that are ambidextrous?
Yes, so that means your when you are ambidextrous, it means that so one thing I didn't mention was that the brain we're having the cerebral hemisphere, one of them is usually dominant. Mostly one is dominant. So if your left cerebral hemisphere is the dominant hemisphere, then you'll be a right-handed person. But if your right cerebral hemisphere is the dominant cerebral hemisphere, you'll be a left-handed person. But there are some people that the right hemisphere and the left cerebral hemisphere are co-dominant, like they are the same. So that person will be ambidextrous. So for that one, the language center can be any part. It can be at the left side or right side. Okay, so very good question. I think there are some other people who say, are you still talking about the precentral gyros? Or this one is a long time. I don't know. Because we are talking about the frontal lobe in general. And the frontal lobe, that's who have the precentral, which is for the motor activities. Then we also talk about the prefrontal cortex, which is for personality. Then we're now talking about this area that is for the primary motor cortex. So you write it down, primary. So we are talking about three things now. In the frontal lobe. So the one for movement, the one for our personality, and personality we are talking about the way you think, the way you reason, your judgment, and all that. Then we are now talking about the primary motor cortex. So primary motor cortex. So write that one down too. Now, so the primary motor cortex is the one that enables me to talk like I'm talking. If there is lesion here, like somebody with stroke, and this part is affected, it means the person cannot talk. So you realize that patient who has stroke and cannot talk, it tells you that the stroke had affected the language center, the primary motor cortex. And if somebody is a right-handed person and they have the right-sided hemiplegia, there's a likelihood the person will not be able to talk because remember, language center is in the left cerebral hemisphere, and the left cerebral hemisphere controls the right side. So if your right side is paralyzed, it means your left cerebral hemisphere is the one that is injured, and it may affect the primary motor, motor speech area, primary motor speech area here. Okay, so we call it primary motor speech area or broadcast. Okay, that's the area. Okay, so that is one thing. So then those three, there are other things, but these three for a frontal lobe is fine. So if they ask you to list three functions of the frontal lobe of the brain, of the cerebrum, we should be able to mention that. Then we come to the parietal lobe. Now, in the parietal lobe, there is also a very important gyrus here. This gyrus coming this way. Good. This gyrus is called postcentral gyrus. You remember this one is precentral. So this one is called postcentral gyrus. You can see it at the top here. This postcentral gyrus is a The primary sensory cortex. So let's write it down. Primary sensory cortex. And what is its function? Any sensation like touch, pain, temperature, whatever, that is where it is interpreted. If somebody is touching your nipple, it will be interpreted at that level. Somebody is touching your any sensitive part of the body, this is where it's coming to be interpreted. So it's called primary sensory cortex. So it detects sensation and then interpret the sensation, and then it will now execute whatever action it's supposed to take. So let's say you step on fire, the heat quickly run here to the post-central gyro for interpretation, and then you so it means that if there is also injury here, you can feel sensation. When the stroke affects these gyros, and then they are touching you, and so let's say the nurse touching you, say, do you feel pain? Do you feel that touch you? You will not be feeling the touch because the post-central gyrus is affected. Okay, the post-central gyrus is affected, and that one is in the parietal lobe. Okay, there's also another area here, very important. This place is the primary, it's like supra marginal. This is the primary sensory speech, like sensory, like when you want to understand the speech, somebody is talking. I will come to that. When we want, let's say I'm talking, for you to understand, it is this area in the parietal lobe that enables you to understand me. Okay, so it's called primary sensory speech area of Wernicke. Primary sensory speech area. So write it down. This one is primary sensory cortex that interpret all sensation like touch, temperature, pain, okay, whatever that is going to the brain, pressure is interpreted. This part of the parietal lobe help you to interpret what I'm saying, understanding your speech. So you call primary sensory speech area of Wernicke. Okay, so that is what happened here. Now there's now connection. There are fibers that connect these two areas. These fibers connect them, and these are called aqueous fibers. Okay, or aqueous fascicles. So that if I speak and you understand me, then the information will now come here for you to interpret, and you interpret here for you to respond to me, because that is the motive for you to respond. This I ask, what is your name? You understand that I'm saying that what is your name? Then the information will come to this part, and that will now initiate your voice, so that you will tell me that my name is Patricia. Okay, that is what happened there. But so it means that if there is stroke and lesion here, what I say lesion, injury at this area, when you ask the person what is your name, the person will not understand you, but will be telling you, oh, maybe you ask what is your name, the person started talking like yesterday, I went to market and all that. The person didn't understand what you are saying, because the primary sensory cortex of speech cortex is destroyed. There is injury to that part, and the person cannot respond appropriately to you. So that is what happened there. So we learn about two areas there. The others, but let's take the two areas, very important for our practice. Then we come to the occipital lobe here. The occipital lobe is the one that have the primary visual cortex. On the top diagram, you see the yellow part, and that one is the primary visual cortex. I'd say do Frimpong. Yep, so you can talk. I'm trying to unmute.
Yeah, hello, sir.
Yeah.
In terms of the accurate fiber that you are saying, If there is
Yeah.
an injury over there, then it means that when you are talking to a person, then the person will be saying different thing altogether. Is there any treatment for that if those things are going on within a person?
Okay. Okay. No. So let me make it. So it is not a yes. So when there is no injury along the active fiber, fine, the person can understand, but the information cannot link up to the motor cortex so that the person will respond. Okay. So the person cannot respond in order. But we are talking about if here that the primary sensory cortex, primary sensory speech cortex is injured. Okay, it's just like the stroke occurring in the motor cortex or in the speech area. You see, when the brain is injured, it depend on if it is severe. It may be difficult that the person will recover from it, but sometimes you just smile, and then with treatment, especially if the treatment is they start physio early and try to train the brain again. Um, the person may be able to talk. If it is severe, I don't think. Yesterday I said the matured brain cells may not be able to talk, like to recover or regenerate. That is what scientifically is there for now. Okay, that is what is there for now. And somebody said, please, what makes someone fully paralyzed? Can it be corrected? Is it the same person? Okay, Elizabeth. So now I've just said it. If the primary motor cortex is affected, let's say what causes stroke? It could be rupture of the blood vessel in the brain. Okay, and that is we call it cerebral vascular accident. So the blood will, they will be on this part of the brain. Therefore, it's compressing on the nerves. And when you compress on the nerves, so you imagine they cannot take the decision, they cannot take the initiation. So it results in the hemiplegia. Okay, like one side of the body. Because we said the right side control the left part of the brain control the right side of the body. So you get that. But if they are talking about complete paralysis, okay, we also, let's say if the injury occurs at the spinal cord, it's different. We'll get to spinal cord, I'll talk about that. But this one, because if you are saying both side paralysis and the effect is from the brain, it means that both cerebral hemispheres are affected. The right side is affected, the left side is affected. So you get total paralysis of the upper limb, lower limb, both, all of them to be paralyzed. So I don't know whether Elizabeth, your question is answered. Then somebody say, I learned it each portion. Somebody say, what? I learned it each portion of the brain is responsible for a specific function. Yes, that's what we are saying. That's why I'm circling. This portion is for a particular function. This one is for a particular function. And if I want to go detail, it will be so like looking at the time. I could go detail and tell you that with each functional area we use numbers, and these numbers are called Broman numbers. We call them Broman numbers. So that if I say primary motor cortex is Broman number 4, so the neurologists use those ones. The Broman number 4 is for primary motor cortex. Broman number 312 is primary sensory cortex. Broman number 44, 45 is the primary motor speech area. So these are specific functions of the brain to a particular part of the body. So if you take even this one, the precentral gyrus, let's say the mouth area is around the motor cortex, the trunk, like your trunk is around here, and then all the trunk top there. Then when you go to the medial aspect, here, this is the medial aspect. So on that one, your testes or genital region is around here, and then the lower limb, so your foot, your legs, and then the thigh area, and then the trunk, then go down to the lateral aspect. Yeah, so what you are saying is right. Every part of the body have a specific part of the body that is controlled. So if that part is injured, that particular part of the body will not be functioning. So that is it. So let me see another question, but we have to go forward. So please, can you go over the lobes again? Hey, you have come on. Somebody to us say, please, how did those functions, finding about the brain and its relatives function come about? Was it, what do you put here? Was it part on the microscope for those finding, or they follow the nest? Okay, okay. Now, recently there was a patient that was treated at what is that, the Rich Hospital. Those of you who heard of it, and the patient was having problem in recognizing people. Like he was recognizing people as animals. You see them as animals. So there was a lesion that was compressing on the part of the brain that enable you to recognize the face, like facial. I'll show you that part of the brain. It's part of the temporal lobe. I've not yet gotten to that. So they open the brain without anesthesia, anesthetizing the pool. They don't deal with general anesthesia. So you see that when they open the brain, the fresh brain, they touch any part of the brain, it will activate the movement in the part of the body that was that is supplied to. So that's how the brain is taken. Okay, these were done. Maybe you can use animal to see, so that when you touch here, you are able to elicit the action on the part of the body. Okay, you open the brain without anesthetizing, and so that it will still be functioning. Then they stimulate various parts, and that will indicate, oh, okay, this part is for here, this part is for here, this part. Then these things have been documented. I don't know whether your question is answered, but that is how you can read more on that. Somebody says, please, beneath the hospital lobe, what is the name of the lobe 2? I don't understand. Isn't this why we are talking? This is a different part of the brain. That is cerebellum. Below or you are talking about this. No, this is the occipital lobe. This one is the cerebellum. We will talk about that. Okay. All right. So let's go to hospital. The hospital lobe. I would say that we have the main function there is our vision. So primary visual cortex. And it's located around here. This one I call calcarine sulcus. Look at it, calcarine sulcus. So the visual center is around this area, like this. Okay, that is the calcarine sulcus. Very good. And that is where we have the primary visual cortex. Down here on the left down of the screen, you can see the yellow part. That is the occipital lobe, and that is the calcarine sulcus, and that is where the visual cortex is located. That portion is the primary visual cortex is the Broma number 17. So we call Broma number 17. Somebody who wants specific. So that area is Broma number 17. Okay. So for vision, so that anything that enters through your eyes, you go to that place to interpret. Like you are seeing the screen, it is that part that is interpreting the information. Okay. So that is what happened. Now let's look at temporal lobe. Let me go back here. So this is the temporal lobe. And the temporal lobe, we have very important function there too. This gyros, now we know what a gyro is, the elevation. This is called superior temporal gyrus. Superior temporal gyrus. And it is the one that is for auditory, that the primary auditory cortex, like for you to hear what I'm saying. I don't know why you are hearing me. So for you to hear, that is the part that will enable you to hear, primary sensory cortex. So it's like Roman number 22, 24, 20, 21, 22, around that. So, but get no, so write it down, temporal lobe, primary auditory cortex, for you to hear. Then as you come down here, the middle temporal gyrus and the inferior temporal gyrus, we have, very important, we have what we call the memory. Like I'm talking, that is the part that is storing the information. So you have long-term memory. We have short-term memory in that. So the primary the cortex, or the cortex for memory, is in the temporal lobe. Okay. So I'll show you another part of the temporal lobe here. Okay, so this portion is all part of the temporal lobe. Let me circle it here. This all temporal lobe. Okay, I've added this one, so it should be from here. Okay, so let's say this is a temporal lobe. You know, we say we have the long-term memory. You see, the inferior temporal gyrus I was mentioning. So for the long-term memory, but this part, the inferior part here, is for the short-term memory. There is the gyrus, this we call the parahippocampal gyrus. Don't worry about that. Parahippocampal gyrus. That's for the short-term memory in that. Then, as you come to the medial here, there is a portion which is for facial recognition. Okay, who is iPhone that has raised his or her hand? Yes, you can talk.
Say, please. Are you talking about the temporal lobe or the temporal lobe?
The temporal lobe. Okay, very good.
Say what? Central.
Temporal.
Temporal. Okay. Okay. Thank you.
Okay. Temporal lobe, and we are talking about a function. So we said this one. I'm on the diagram up here. Okay. This one, the thing is small. Yeah. This is the primary auditory. Okay. Then we have long-term memory. Then when you come inside, we have a facial recognition. Okay. Facial, like if I see you today, next time I see you, I should be able to recognize your face. That is what is there. And they will also have the long-term memory around the parahippocampal. So temporal lobe is for memory. So when there is injury to the temporal lobe, it means your brain will be formatted. If that is computer, is that not it? Whatever thing you've learned, okay, whatever thing you learned will be taken out from the brain. That is what it means. It will be out of the brain. So you have what we call retrograde amnesia. Okay, or we have if it is a short-term memory part, you have what we call the anterograde amnesia, where you just forget recent things that you've done. But if it is the long-term memory part, then things that you learned when you were a child upwards up to today, everything will be gone. Then we call it what is that? Retrograde amnesia. Amnesia in that. Okay. So those ones, when there's leaching there, that is what will happen there. This area that is called the uncus here is for smell. So this is a portion that is for smell. That's where smell is interpreted. It's still part of the temporal lobe. Okay, it's part of the temporal lobe. Okay, so here, very good. You can see this diagram. I'm circling the diagram, this one. When you are looking at the brain at the top, you can see this side is the left and this side is the right cerebral hemisphere. Okay, that's the right one. So you can see there is a groove, a fissure between them. So if you look at the cerebral hemisphere, and in between them, we have the longitudinal cerebral fissure. So this is the left one, the right. So frontal lobe, parietal lobe. Also the yellow one is occipital lobe. Okay, those are the different. Now we've learned about the four. Then there's another loop. If you open the central, the lateral sulcus, you see another part of the brain, another loop, and this one is called the insula. Look at it, the insula here. So let me mention the 5 lobes of the brain. These are frontal, parietal, occipital, temporal, and insular. Now the insula actually doesn't have much function. Okay, so don't worry about that. We just leave that. But the other 4, they have function. Okay, that we need to know. Okay, so those are the parts of the brain and the cerebral hemisphere, their function, and all that. So if you want to read, I'll give you this thing so that the reading part are here. So all the things we talk about, central sulcus, parietal, occipital, lateral sulcus, they are there. What is a gyros, elevations, and what is a sulcus or sulci? These are the depressing, and these are the stereo division that we have. Yep, so these are showing a diagram that indicates. And this is the insular part which we open there. Very good. And then we'll talk about now when you cut the brain, the outer part is usually made out of white matter. Okay, and they're the periphery. And the inner part, and the outer part is the gray matter, and the inner part is the white matter. White matter because it's myelinated. And then this listed the functions of the loops. Okay, there are just some. I ask you to write others. So like parietal lobe, we only put the primary sensory area. Occipital lobe, we have the primary visual. Frontal lobe, the motor, that's the primary motor cortex. Primary speech area. And they will have the thinking, that the personality, thinking, judgment, reasoning. Temporal lobe, we have the auditory, emotion, memory, and then yep. So those are the functions that are summarized. Then, like I said, if you cut the brain, you see that the peripheral part is gray like this. Okay, the peripheral part is gray. Don't they? Yeah. So when you cut, okay. So let me see some questions before we continue. Somebody saying what? I think there's no question. Okay, Edward hand is up. Edred, you can unmute.
Yeah, sir, please. When we say motor activities,
Yes.
what does it mean?
Okay. So motor. You know the car. We have the car is a motor, right? A car is a car a motor or not? A vehicle. Hey, or you are okay. Let me see. Yes, okay, so I know you are off again. So what happened is that a vehicle, okay, let me unmute you again. So you can unmute.
Yeah, okay, sir.
I was asking, maybe you are aware a vehicle is a motor.
Yes, please.
And what is the function of a vehicle?
It moves.
It moves very good. That is why we say motor. So when we say motor, we're talking about movement. So when we say primary motor cortex, it means that part is for movement and it's in the frontal lobe movement. You get that? So
Yes, please.
that is what it means. Cynthia, you can talk.
Hello, sir.
Yeah.
Please, concerning the temporal lobe,
Yeah.
you said its function is for memory. So,
Exactly.
yeah, the question I want to ask is there any way that it can be controlled? Because when you have either long-term memory or short-term memory, there are incidences that happens in your life you can never forget. But let's say, for instance, now what you are teaching right now,
Yeah.
I can decide to forget it, and then that is the end. But there are times that, yeah, there are times that things happen that you will never forget.
Okay. Okay.
Yeah, so that is why I'm asking, is there maybe a portion of the brain or a part of the brain that can control that part of the temporal lobe? Thank you.
It's true. Yes, Cynthia, this is very true. Now, and that will let me talk about something like how we should ensure, like, to retain whatever we are learning. Now, the brain is able to store information based on how you reinforce that particular information, how dear that information is to you. Okay, so like if every time I've been teaching this course, the brain is going to store that one at the upper shell, like the things in the brain are stored in the form of shells. If you have a like shell, you have the upper shell. And let's say your kitchen, you have the kitchen cabinet that has a different shells. Now, the brain will put things that are dear to you. Like you were talking about, maybe there's some emotional pain or there's some loss in your life that is really dear to you. The brain will store that one in the upper shell. Or the way I'm teaching, you want to keep this thing in your mind. Like when I finish, you go and read again. Then tomorrow morning, you look at the thing again. The next day, you look at it. Even the night, you look at it. As you are reinforcing the thing, the brain will put it at the upper shell. But if I teach like this, and you get up and start working, you go to cook, you go to work, and you are working, you don't think about it again, the brain will put it down, down to the down shell. And for some time, you don't even remember it again because it means you are not interested in that particular thing. So it will push it down. But if you say, okay, you are telling the brain, I need this thing. This is important to me. The brain will put it at the upper shell. So that anytime you just get up, you are able to remember. That is how the brain saves things. So that is why some things you can't forget. Maybe that particular thing pain you. That particular thing was a very great impact in your life, and the brain will put it at the upper shelf, and you will never forget it. So that is what happened. Cynthia. James. Yeah, James. I'm on mute too. You can unmute.
Thank you, sir.
Yeah.
Please, my question is: when they say somebody's IQ is very high,
Okay.
like what part of the brain are they, talking about that is very, very high?
Very high. Yes. You know, we talked about the memory part. Then we also talk about the part that is for thinking deep, the frontal lobe. That is the part that makes you to think deeply. But if you think deeply, you have to save it. So it's not really a specific part, but it's a coordination of several parts of the brain, like the frontal lobe, the memory part. Because if your IQ is good, mean that whatever you read, your thinking, your judgment is safe. Okay, it's safe in a particular in the temporal lobe where I was showing you. So it's not like maybe this specific part, but it's coordinated between the frontal lobe and then the temporal lobe. That means you are able to keep things. And as you are young, the brain stores things faster than now you are old. So now what you need to do is to reinforce and to try to understand. But when you are a child, when you read once, because you see the brain, like I say, the shells are many at that time. You just read once, second time, the brain is able to store the things for you. But as you are aging, your brain cells are also aging. The only help for you is for you to understand what they are teaching. If that time you can think, your thinking ability is more than the when you were a child. You see that? So that's why your maturity, the way you think and care, your frontal lobe is now more mature, and you can think and understand and apply this time. Not necessarily trying to get memorize the thing, but you understand and apply it. It will help you that memorize it. Can we go on? The questions are becoming too many. Somebody said movement, motor. Okay, yeah. So that is what we are talking about. Yeah. Okay. So last question. Last question is from Newman. Newman Duku. You can unmute and talk.
Sir, please. I would like to know which food nourishes the brain most, so that in knowing this, we'll be able to help our children to become smarter. Thank you very much.
Thank you, Newman. So what happens is that as we are growing, the brain needs protein. Now, listen, and we're saying that yesterday we said there are some cells that malinate the brain, and these cells that the oligodendrocyte malinate the brain. And so brain cells that are well malinated, the axons are covered, they speed up impulses transmission. And therefore you need more protein diet as you are growing up, so that you get more malination, and you also need an environment that is stimulating. So environment that is stimulating in that the other thing that makes you intelligent is you see, yesterday we talk about dendrites, and we talk about how nerves connect. Now you can have one dendrite, one nerve connecting to several other nerves. Okay, so in order for you to be very intelligent, you need a lot of connections, not a political connection or those connections. The connection in the brain from one dendrite to other, like one nerve connect to several. This will enable you, so the connectivity in the brain help you to also think faster and judge faster and do things faster. That makes you intelligent. Okay. So during as a brewer, getting food that is balanced diet, let me use that, will help you in these processes. Neuronal, like the astrocyte, a lot of astrocyte, they direct this connectivity in a way. Okay. And then the stimulating environment also help in more connection. Look, they think that if you are using your brain, you get more connectivity. But if you are not using your brain, the connectivity will be fewer. And then your thinking capability and all that will also be low. So, but we are not also saying it's all environment. Other things, genetics also play a role in intelligence. So it's a nature nurture argument. Genetic contribute. Like so, you inherit some intelligence gene from your parents, and then the environmental stimulation help in what we call brain plasticity. That is how the brain interconnect, the cells interconnect, and therefore it makes you very intelligent in that with high IQ. Well, Newman, your hand still up. So we have to go on. We have to finish this. Okay, so Newman, is it a follow up or in the old hand? Okay.
Yes, it's a follow-up.
Okay.
Sir, please, one thing that people have been saying, and sometimes I don't know if it is true, so I want to get, you see, when, for instance, a woman is pregnant, or let's say even the man is let's say as I'm studying now in school, and by so doing, maybe my wife and I we meet and she take a seat, and she is also studying in that once she's pregnant. It is assumed that the child that is produced become more intelligent because when the mother was pregnant, she was learning, or if it is whatever thing you are doing, the child, when you give birth to that child, she picked up that thing that you were doing. How true is that? Thank you.
Wow. I don't really. Maybe I have to research to that. I've not. I don't know how that would be. That what you are doing is really affects the inborn child. Okay, so maybe this is something I have to also look at. Okay, I can't confirm or say that is not true because now knowledge is everywhere. So let's go on so that we'll ask questions again. Somebody say it's not true. I just say it's not true like that. In a situation that a right-handed person loses the hand and has to adjust using the left, are there some peculiar changes that goes on in the part of the lobe? Very good question. Very good question. Now, like I mentioned, something like the brain plasticity. So, and then did your question also linked to, let's say, if somebody has stroke and they are doing physiotherapy, how come maybe for some time the person may gain some movement? Though we said the brain cell will not recover. Then what happens? It's because of the brain plasticity, like the connectivity I'm talking about. The brain. So let's say I'm thinking about moving my upper limb. There's a pathway that the brain will pass through so that to enable me raise my hand. There's a pathway for that. Now, if that pathway is injured, then what happens? If you are doing the physio, or like you said, you want to readjust you were left-handed and your parents force you to readjust, your brain will start to create different pathways so that you'll be able to perform that particular procedure, because the original pathway is blocked. Like just recently, we have rain that is always carrying away some part of the road. Then the government will create a different pathway for the vehicle to still pass. So you see that. So they are creating different pathways because the original pathway has been blocked or is injured. And that's what we call brain plasticity. Okay. So if you are trying to use a different, let's say you are right-handed and you are left-handed and you want to use the right, then as you are learning, the brain will try to create different pathways so that you'll be able to use that. Okay, so I think that is what happened. Somebody say, I want to get pregnant now. Please, who is? Hey, Gloria, be careful. Be careful, why? If you want to get pregnant, go to your house. So it sounds mythical. We need to do research. Yeah, so that's why I say we should do research. It's true. An example. Hey, Cynthia. Okay. So please, if the hospital loop is injured, yeah. So we say the hospital loop is for what? It's for vision. So if the hospital loop is injured, it means you can't see again. So if you want to blind your rival, you just hit the hospital part of the head, and then the person will be blind. You will see your husband again. The place, the person affects which part? Depression, that the frontal lobe. I was just saying it, mental condition. Because that the part that makes you to get things, to reason, but there is also the temporal lobe have emotional component. So emotion can affect like emotional outbursts may affect that particular the temporal lobe, which is for memory and for auditory and for others. So let's move ahead. Let's move ahead. I hope there are no people at the YouTube because this one is not even full. I hope people are not there. If they are there, I've not been checking. YouTube people. Let's see what is there. Okay, so this is the brain that has been cut. And then you see that at the peripheral part here, we have gray, so that is gray matter there. Okay, and then here is white, so we call it white matter. The gray matter contains the cell bodies. So they contain the cell bodies, and then the white matter contains the axons, which are myelinated by the oligodendrocyte, the axons. So the axons are moving from the top, that is from the cortex, cerebral cortex, all the way to the spinal cord, and then to connect to other parts of the brain. So that is what we have. Now, within the gray and the white matter, there are some gray area like here. And then you can see the other side, this one too. So these are gray areas. One, two, yep, here. Okay. The same thing here. These are gray areas. These gray areas within the white matter are referred to as basal nuclei. So they are basal nuclei. Okay. Then they include, you can see this part. So let me put one there, one there. That one is called coded nucleus. Coded nucleus is here. So that is the head of the coded nucleus. Okay. Then we have this one, the whole of this coming this way. That one is called lentiform nucleus. Lentiform is here. Those who are watching here. So that is lentiform nucleus. It's made out of two parts. We have this outer part called putamen, and then this place called the globus pallidus. This is the putamen, and then we have the globus pallidus. The two together form the lentiform. We have another small part. I've drawn the line on it. That one is called colostrum. So we have three parts or three basal nuclei. These are basal nuclei. So let's write them down. So just write basal nuclei are gray matter in the white, in the area of the white matter of the brain. And what is their function? Okay, so let's list them. So we say we define it first. We say the basal nuclei are gray matter, and we know gray matter are collection of what? They are collection of cell bodies or group of cell bodies. That's why you said they are basal nuclei, nucleus, collection of cell bodies in the brain or spinal cord. So they are collection of cell bodies in the white matter. Let's put it that way. Collection of cell bodies in the white matter of the brain or cerebral hemisphere. And they are coded nucleus, lentiform nucleus, and colostrum. Their function, they coordinate voluntary movement. So coordination of voluntary movement. So if I think of moving my hand, I want to pick my phone on the table. So my brain from the primary motor cortex initiate the movement of the hand. But it should go to where the phone is, then pick it up. It goes to where the phone is. So it coordinates the movement. So they bring about precision of the movement. So if there is injury, so let's see, injury to the basal nuclei result in either exaggerated movement or lack of movement. Like tremors. Tremors, okay. Example of conditions or basal nuclei disorders includes Parkinson's disease, Parkinson's disease. So let me see whether I have. Oh, I didn't leave them here. Okay, fine. Then Huntington chorea, acetosis. Let me write that one. Is acetosis. So we say Parkinson disease. Okay. We also talk about Huntington. Huntington chorea. Okay, Korea movement like this. Okay. The acetosis. There's one they say hemibalismus. Hemibalismus. Okay, so you can check the folder. So this, like the Parkinson disease, the person doesn't is not able to move. It's just so rigid. You can't move. So there's poverty of movement in that. And autism Korea, there's exaggerated movement. The person have dancing form of movement. Okay, the whole body is moving uncontrollably. Okay, I'll repeat. So we are saying that we are talking about the basal nuclei. We say the basal nuclei are a collection of cell bodies within the white matter of the cerebral hemisphere. And we listed three of them: caudate nucleus, lentiform nucleus, and cholesterol. We say their function is to coordinate voluntary movement. And injury to them results in exaggerated movement or poverty of movement. Example of basal nuclei disorders include Parkinson's disease, Huntington chorea, acetosis, and hemibalismus. Good. So that's what we talked about it. Then, still on the cerebral hemisphere, there's also a portion that we refer to as the diencephalon. Okay, let me see. Some people have questions. I mean the YouTube are down. Which part of the brain is responsible for feeling headache? It's pain. So where do we interpret pain? Primary sensory cortex, that is parietal. Somebody said, please, your writing on the screen is not clear. Can hardly see. Okay, this one. Please try and see why. I don't know. Let's see YouTube. So I'm there now. Any message? Please go over which one. So please, WhatsApp. Okay, what are you talking about? Please, I can't hear. Okay, I don't know when you had this one. Okay, so let's continue here. Now, so the cerebral hemisphere also have this part, and this area is part of the cerebral hemisphere. Okay, remember we talk about this part. This one is the corpus callosum. So we are just, and this is the lateral ventricle we were talking of yesterday, and this area is, we call it diencephalon. Okay, that is diencephalon. This diencephalon is made up of, so let's write the diencephalon. We have this one called thalamus. So this area is the thalamus, and this is the hypothalamus. I hope you heard of hypothalamus before. And then we have the pituitary a stalk, that the pituitary gland continuing down. So the cerebral hemisphere, like we're talking, is also referred to as the telencephalon, and then we have the diencephalon. So they are the two. But we say diencephalon is now made out of thalamus here, and then hypothalamus, then epithalamus, and then some other minor things. That forms the diencephalon. Now, what is the function of diencephalon? Okay, that is the thalamus. Okay, so this is a larger picture of that. So this area is called thalamus. You can see the name here, thalamus here, and then this area, the whole of here, is called hypothalamus. You know, hypo, that means below the thalamus. And then the top here, just a small area here, we also refer to it as the epithalamus. So this thalamus, hypothalamus, and Ibrahim, you have a question.
So this one is not entering. Oh.
Really apply saliva. The last I told you how to let it enter, is that not it? When something is not entering, what do you do? And now you are even at home. You should apply saliva now.
Okay, sir. Thank you. I'll add oil.
Thank you. I didn't even know. You have KY jelly, you had. So try to let it enter. So hey, okay, is your hand up again? We have a Kaku.
No, please.
Kaku, your hand is up. Or it's a mistake. Where is Kaku? You can, okay.
Sir, I'm totally lost. So.
You are lost too.
I'm lost. I'm not getting anything. So please try and go over again for me.
Okay, I'll go over. Sorry. Are you in which forest are you in like that? Are you in Achimota forest that you are not like that?
No. I'm not getting it. So please go over for me.
Remember that forest has been given out for.
No, I'm not
forever.
in the forest. Okay.
Okay. So we are still talking about. Okay, so let me do something so that I'll bring you back from the forest. If you are able to, very good. You see, if I'm here, so what I'm saying that you see, we say the whole of this part, drawing this way, up is our cerebral hemisphere. So like here, all is our cerebral hemisphere. Is that not in one part? So you see that the cerebral hemisphere is made up of this portion, that the bigger portion we have talked about, that is the tail encephalon. Then you see the part I'm talking of is just here, this area, like this, and this area. And we said that part is called diencephalon. And the diencephalon is made up of the thalamus, which is here. So this is T here. And then this part is called hypothalamus. Okay, this is hypothalamus. Okay. I don't know how you gotten to this point. If you are here, then you are not in the forest. So we are not going to say what is the function of thalamus. Okay, then what is the function of the hypothalamus? Then we look at the clinical correlation, and that is all we are talking. So let's go back to where we were. Okay, we are able to get to here. So this way, so that plate I drew is now. So you see the portion here. I said that is hypothalamus, and this one here is the thalamus. Okay, we have gotten to this point because you are not lost. So now you see diencephalon. If you look at the slide, diencephalon. So where we have the thalamus, so the thalamus is a major relay center to the cortex for all sensations. Like we're saying that the cerebral cortex, that the primary sensory cortex, is where all sensation go to. But it has to pass through the thalamus. The thalamus cells are the secretary to the primary sensory cortex, so that if there is pain, the pain passes through the thalamus. And touch, it passes through the thalamus. When you see something, it passes through the thalamus. When you hear something, it passes through the thalamus. Then the thalamus will now redirect to where it's supposed to go. That is what we are talking about. So the thalamus is a major relay center, except smell. Okay, except smell. The hypothalamus controls many functions, including hunger. If you are hungry, taste, pain, pleasure, and the sex drive is from the hypothalamus. And we know hypothalamus also produce a lot of hormones, regulatory hormones, to the pituitary gland. So it serves as a link between the brain and the endocrine system. That is hypothalamus. So it controls things like pain, temperature, taste, hunger, pleasure, and sex drive. That is hypothalamus. So that's what I wanted to get at. Then we'll now look at the next part of the brain. If you recall, we'll say that the brain is made up of three main parts, and these are what? Cerebrum. So we have cerebrum, I'm writing it here, and we're done with it. And the cerebrum is made up of the two parts. That is the cerebral hemisphere that we call tail encephalon. Okay, tail encephalon. Then it has the diencephalon. So we have talked about tail encephalon and diencephalon. Good. Now we are coming to talk about the brain stem. That is the second part. So 1, 2, and then after that we'll talk about what? The cerebellum. And that is about the brain. Now I will tell you how to memorize or how to keep things, in that you should also organize your thought very well. The thing you are reading, you should organize it very well. That's why I'm always trying to go back and let you reorganize. And also a form of reinforcing to the brain that this is important. Keep it in the temporal lobe. Okay. So 2 hands are up. And let me give to Deladen first before James. Yeah, Deladen.
So, you said the thalamus is a relay center for the cortex for all sensations, and except for smell.
No, yes.
So which one controls the smell?
And so the smell, I show you a place, the uncus. I don't know who were talking about the temporal lobe. Uncus.
Yeah.
That is where the smell is interpreted. You get that?
Okay.
And maybe
yes, sir.
But there was a place I show you who were talking about temporal lobe. It's called the uncus. It's like this. I'm trying to write it. Okay, UNCUS. Uncus. So that is fine.
Okay.
Then let me give chance to James. James down.
So I was going to say, what's her name? The next lecture, no, this one we need to think about it so that it will stay in the temporal. If you add this one, there will be a plenty mixture.
Oh, the brain can store a lot of things. James.
Yes, sir.
At the end of our lifetime, we use 5% of our brain, especially if you are not reading and using it. You just use 5%, and then you bury the whole brain. Please, let's use the brain. It can take a lot of things. So don't worry at all. So at this one will not be anything difficult. Because of time, let's just run through this. I will not start the cerebellum so that next lecture I will do the cerebellum. But let's finish the brain stem because we still have some time. Okay.
Okay, sir. You say.
Thank you for understanding. The brain can
Okay,
store
sir.
a lot. So let's use the brain. Let's use it. Let's
No.
read and think deeply about things. Use the frontal lobe. That is for thinking. Thinking deeply. All that. Okay. So the brain stem. Hey, you people, will I ask a question? Oh? Okay. Ibrahim again. Ibrahim. Anything? Or mute, or mute. Or I should.
Thank you, sir. If I heard you well, the hypothalamus.
Yeah.
You said that one too is responsible for a sexual drive.
Yeah.
I want to find out. A lady who doesn't have libido at all as a result of rape, maybe rape in the early ages, say 6-7 years, and she's a grown-up lady now and doesn't have libido for sex. What could be the cause?
Okay.
Does it mean there is?
Yes. Yes. You see, you have brought something. There is you are saying there's emotional attachment to what you are saying. So the person has suffered. Somebody asked this question. You know, the temporal loop will store that thing and will serve as a fear factor that is stored there, and that will affect the hypothalamus. Okay, that the brain they coordinate. Why is it that maybe as a man you see a naked woman, then your penis start to erect? That means there's your thinking. You see that there's a higher power of your frontal lobe will think about it. You've seen a naked woman, and information run through the brain, goes to the hypothalamus, stimulates it, and you see it goes like. Okay, I'll not take you male reproductive. If you learn about factors that stimulate erection, especially in males, it is not only touch. Touch can also stimulate it. Even, for instance, erection in male, they can be at the spinal cord because it may not be conscious level. Yes, it may be at the conscious level, but at the lower level, that can bring about erection. Okay, so there are a lot of factors that will come into play, Ibrahim. Yeah.
Okay.
The emotional factor will affect it. Yes.
If I'm not diverting too much, saying that the issue of a man getting erected or sexually aroused for a woman, say a man and his wife, sometimes in a direct nakedness of the woman to the man, he feels he doesn't have any desire, he is not sexually aroused whatsoever, but seeing a different woman calls for this sexual arousement. I don't know. What could also be a reason to this?
This man, the women will not be happy with that.
They should pardon us, please.
They will not be happy with what you are saying, but it's all psychological.
Okay.
It's all psychological, and men, the brain is in a way that is they want to exploit other, okay, and that makes them polygamous in a way. So they want to exploit. So once you tested this one, psychologically, the feeling for that one reduces. Then
Okay.
you want to explore other ventures. And the women will not be happy with you for thinking like that. So let leave that one. If not, when the women come, they will beat me.
Thank you, sir.
Okay, yes.
Yes, sir.
So now let's look at the brainstem. The brainstem is the livestock of the human body. The livestock in the father, that is where you have the vital centers of life are located there. For example, the cardiac center, the respiratory center, and those ones. And the brainstem and the cerebellum, they work under unconscious level. It is not the cerebrum that we learn, the cerebral hemisphere. That part is the part of the brain that we get to be aware of where we are. The brainstem is subconscious or the unconscious part. That means activity go on there without the person controlling them. But the cerebrum, activity go on there because I initiate it. I'm aware that my hand is moving. I'm aware that I want to raise my leg. I'm aware I'm in the office. And then you are aware wherever you are. I don't know where you are, bed with somebody. I don't know. So you are aware of where you are. It is the cerebrum that makes you that. Okay. So now we're talking about a part of the brain that works without you being the one controlling. That is subconscious level. That is brainstem. And the matter of the midbrain, the pons, and the medulla oblongata. Very nice name. So we'll take each of them and look at it. But there are a lot of questions at the chat. I don't want to go there. Now, I'm going to look at this one. This is the brainstem, the whole of here, coming down this way, then this way. That's the brainstem I'm drawing. Okay, good. That's the brainstem. So they made out 3 parts. So did a division. This is one part, another part. Good. Then this first part is the midbrain. So M, let me use M for that. That's the midbrain. Then this one is the pons. So P for that. And then this is the medulla oblongata. So that is M, O for that. Very good. So these are the 3 parts of the brainstem. And I said it acts under subconscious level. For instance, your heart is beating, you are not the one causing it to beat. You are breathing, you are not the one doing it. Those are subconscious level. Okay. So the midbrain is just a small part just below the diencephalon. That is thalamus and hypothalamus. And then the joint to the pons inferiorly. The pons is there. When you look at, very important thing I want to talk of is there's some raised area here, this place, and another one here. Now there are usually 4, but because this one is half, that's why it's looking like this. This part is called superior colliculus, and this one is inferior colliculus. Now the whole of this part is called tectum. Tectum. And then where I put the M is called the tegmentum. Then there is the cerebral aqueduct, yesterday we learned that the cerebrospinal fluid from the diencephalon passed through the cerebral aqueduct and then poured into the fourth ventricle. So did a third ventricle here, passed through here, poured in here. Okay. So the tectum, we have this part called superior colliculus, and this is inferior colliculus. The function of the superior colliculus is for the human body or the human being to detect the source of light. If you are in darkness and maybe there is light coming from somewhere, you'll be able to tell that this light is from here. Either your right side is coming from your back, your front, or that. The direction of light. That is superior colliculus. Then the inferior colliculus help you to detect the direction of sound. So that if somebody, you hear gunshot, and the gunshot is coming from your right side, or it's at the top, you'll be able to tell the part that it is. Okay. All right. So sorry, somebody was. So you'll be able to tell where that is. Okay. Okay. Sorry, somebody was. You say located from the between the diencephalon and then um, the pons. Okay, that the pons and cerebellum and that. Then is about is very short, so 2 centimeters, and the cerebral aqueduct pass through there. Another thing that we can find there are the cranial nerves. Remember, the peripheral nervous system have cranial nerves and then spinal nerves. The cranial nerves are 12, like I mentioned yesterday. So 2 of the cranial nerves have their nuclei in the midbrain. The cranial nerves are named using Roman numerals. Like cranial nerve 1 is CN1, cranial nerve 2 CN2, and then you see cranial nerve 3 CN3 here, then CN5, cranial nerve 5. But they have their actual name. Like cranial nerve 3 is oculomotor, which you are supposed to learn, and then cranial nerve 4 is a trochlear. And so when I mention nucleus too, you understand that they have their nuclei in the midbrain. So that means their cell bodies are located within within that part. Okay. So that is what happened there. So let's know some of those things. Then we said the pons is also the left side of the pons is situated anterior to the cerebellum. Let me go to the picture. I like using the picture. We are going to create a key first. So this is the pons, the P. You see that posteriorly we have the cerebellum, and inferiorly we have the medulla oblongata. Superiorly you have the midbrain. Okay, so that's what we are describing. And posterior to that, have the floor of the foreventricle, which we talked about yesterday. So the point is situated, so we try describing it. It also have cranial nerves. Okay, so this showing a larger part of the pons. So this is the pons. And see, these are cranial nerves coming out from it. So we have 4 cranial nerve nuclei. That the cranial nerve 5, 6, 7, and 8. Their nuclei are located there. So when you go, one assignment is that try to learn all the cranial nerves, the cranial nerve 1 to 12. Okay, cranial nerve 1 to 12. Learn all of them. So the first 2 are in the cerebrum. That is we have the olfactory, the optic nerves, and then the second 2, that's those in the midbrain, that is the cranial nerve 3, cranial nerve 4. They're in the midbrain. Then I was talking about cranial nerve 5, 6, 7, 8. Their nuclei are in the pons. So cranial nerve 5 is called trigeminal, cranial nerve 6 is this one is called abducens. 7 here is called facial, and then this is cranial nerve 8 is called vestibulocochlear nerve. Vestibulocochlear nerve. So these have their nuclei within the pons. Within the pons too, you have the cardiac center, respiratory center, and those ones. Yes, because it's part of the. Okay. And so yes, so these are the cranial nerves in the pons: trigeminal nerve, abducens, facial, vestibulocochlear. So let's know all this. And then the medulla oblongata is also part of the brainstem, that the inferior part of it, and is continued downwards with the spinal cord. It also has those vital centers, and it also has the last 4 cranial nerves. That is cranial nerve 9, 10, 11, and 12. So cranial nerve 9 is the glossopharyngeal, 10 is vagus, 11 is accessory, and 12 is what we call the hypoglossal. So that is your assignment to go and learn all the 12 cranial nerves and their function. So write the assignment down. So write it down. That is your wherever you are. You can just Google it and do that. Okay. So those are the cranial nerves that are there. Okay, so we'll just we are almost done. We are just doing a review. Like I said, the cerebellum, when we meet, we'll talk about it again. So here we have this. It's just revision. You can see, so this is the front part. So this one is called what? You can get type. This one is called, so let me say this is E. Your question would be like that too. So I'll bring E here. Maybe this one is B. We should name, identify the part. This one is C, and then this one is D. Okay, very good. So this is how some of your questions will be tomorrow or Friday. The classroom should decide where we should write. So identify A, B, C. So A is what? B is what? C is what? Very good. That it looks. So frontal, parietal. Okay, so these are the answers: frontal, parietal, occipital, and temporal. That is what I'll be expecting. Yep, and here too, you see this gyri. So this one E. So identify E. They identify B. Okay. Then I'll ask what is the function of B. So I can even put here to C. Okay, I can put somewhere here D. And say what is the function of D? Then I can put somewhere here E. So say give the function at the CDE or ABCD. So you see A, what is the name? Which gyrus is that? That is pre-central gyrus. The B is the post-central gyrus. And what are their functions? So A is the primary motor cortex. B, the primary sensory cortex. The C is for auditory. D is for what? Primary motor speech area. And then E area is for personality, thinking, and all that. Okay. So those are the things. Precentral gyrus for primary motor cortex, and then postcentral gyrus for somatosensory cortex. Very good. Very good. So you can see this one too. Okay, I can even bring this. Then we can see what is here. So what is the name of this one? So let's say this E. Identify E. Very good. You can see this color, which sulcus is this? So this is the parieto-occipital sulcus, and this is calcarine sulcus. So that is where you have the primary visual center. The A is the corpus callosum. Then you can also try to identify here. So let's use here is B, identify B. And this one is C. Okay, identify C. Then we have D here. Okay. We have not done this one yet. Okay. So I'm just trying to give you the questions, all the questions that will be coming. Who is it? Asedu want to talk? Yes, Asedu.
Sir, good morning.
Good morning.
I'm coping with all what you're doing, but if all what you've done on the diagrams can have, let's say, a slide note on it, then it will really help us. Because during our nursing, we did not go into details with this type of anatomy. So if you can get us,
but you are not 3 degrees, so that's why it's a detail.
And okay, the out of the slice, if you're able to get it early, so that you can.
I'll put it on the red page, the class red page, so that they will send it to you. So that one is not a problem. Okay. So, but you can use there's a bit of text, but I like the pictures. I like the pictures more. All right. So no problem. Just read print form. So here we have, so A is what? Corpus callosum. Okay. B is our midbrain. C is the pons. D is medulla oblongata. Very good. So we are done. So calcarine sulcus and parieto-occipital. And you see here we stated visual, primary visual center. Okay. Primary visual. Okay, so yep. Okay, so this is another gyrus which I don't want to bother you, singulate gyrus. And then so this is the base part of the brain. So you could see we have the pons, the midbrain is the blue, the green is the pons, and then medulla oblongata. So they are all parts here. Okay. Then this is the optic nerve, olfactory. You know, we're saying that olfactory, that's for smell. Then we have the optic nerve, that's cranial nerve 1, 2, then cranial nerve 3, that's the oculomotor. Cranial nerve 4 is here, that is the trochlea. Then cranial nerve 5, trigeminal, that is this one. Okay, then on and on. Cranial nerve 6 is here. Okay, so that is what is being olfactory and all that. So I'll give you all these ones and all that. All right, so these are other try questions that you should look at. So something like, which lobe is the area of your brain responsible for thinking deep thoughts, reasoning, judgment? It plays major role in problem solving, recall, motivation, language, judgment, impulse control, social and sexual behavior. So which of these lobes will deal with that? The frontal lobe, parietal lobe, occipital, temporal, or insular? Very good. So those are some of the things that we should look at. Then the primary auditory area is located in the, which of the lobes contain the primary auditory? This one everybody should get it. Get it too. So that is the frontal, parietal, occipital lobe, insular, and temporal. So answer it in your book. Then we did some of these yesterday. We said that is accumulation of cerebrospinal fluid in the brain as a result of obstruction of the ventricular aperture or overproduction of the cerebrospinal fluid. Very good. So you should just fill in there. Then the third ventricle of the brain is connected to the fourth ventricle by the cerebral aqueduct. Okay, cerebral aqueduct. Very good. So we'll end here so that we have the spinal cord. So we'll do the cerebellum and then the spinal cord. Then we'll be done with the central. Then we'll look at the peripheral. Any questions? There are a lot of messages, about 90-something messages. Okay, yeah, some were answering the question. Very good. But today I'm not giving marks. Sorry, today I didn't say I'll give you marks. Answer it yourself. Okay. Does any part of the brain cause body jerking? Yeah, tremors. So it could be tremors. I don't know why you are talking about tremors. So yes. When we talk about the cerebellum, injury to the cerebellum will result in those things like tremors, and also the injury to the basal nuclei will also result in tremors, like we're saying. Okay, so that is it. Yep, somebody had answered them. Very good. Frontal, parietal, occipital. Yeah, that's good. Please don't try to get a slice. Yes, that is assured. Somebody to answer this one. Oh, yeah, all shots. Corpus callosum A. Yes, frontal lobe. Okay, E. Please try to pass. Please, temporal lobe for auditory. Oh, I'm happy. Hydrocephalus. Yeah, hydrocephalus. That's good. So I believe everybody has answered them. How? Any question? I think I've also recorded the thing. So let me see. Yep, they like them. I'm coming. Let me. They like them your question. Or
Yes,
me?
sir. I wanted to ask how the IA is going to look like. How we write it? Because some of us, our network is always not stable. So we
But
want to know how it's going
I
to.
think it would be Zoom, like, and the question that I did show you like that. It will be Zoom. So you get open, and there will be a time. I'll give you a time limit, maybe 30 minutes or 20 minutes. So when it's time, I just close it. You can't answer again.
So then how will we be replying?
I don't understand.
Like when you project the questions on Zoom, then how do we give the answer?
I'll give you a link. Okay, it's not Zoom. I'm not projecting on Zoom. What happened is that the Google form, I'll give you a link. Then you open the Google form and answer it on your device. Then there will be a place you click and submit.
Okay.
Okay.
Thank you.
And so when submit, it comes to me. So by the next day, you get your result.
Okay.
And so don't worry.
Okay.
Mukaila.
Good morning.
Yeah, good morning, Mukaila.
Doc, please, about the IA. I want to plead if it can wait till we come to campus because most of our colleagues are living in the villages where there are no networks.
So does that mean that they are not attending lectures?
Some of them are trying to attend, but they are on and off.
Oh. You see, it will also help you better than you coming to campus. I don't know. If we all agree that we are writing tomorrow or Friday at a particular time, I don't know whether you can make an effort to get somewhere and get this. So let's try. I've been doing that and it works. I don't know. And you are all it's still the same. Those previous groups, they were Ghanaians. They were still in Ghana and we are still in Ghana. I don't think. So Mukala, I think we should really consider it. Let's try it and see how it goes. Okay. Anybody else? If not, who gets close. Okay. So I believe everybody is satisfied with what we have done. We'll continue to read. Okay, K.
So my suggestion is that if we can know the date of maybe we can move to more stable network.
If what?
If we are able to, if we know the date and the time, maybe we can move to somewhere where the network is stable and then we try.
Yeah, so you don't have problem. Let's make it. It's your time because you are having lectures. So that's why I don't want to give my time. I want to ask the class rep on the page so that if they know that maybe you will be free just 30 minutes. Like all of you will be free just 30 minutes from this time to this time. Do you get that? Then I'll fix the time at that. But let's imagine I say maybe tomorrow 5 p.m. and maybe some of you are having lectures. It will not fit. By week you can say okay maybe Friday between 12 1. You all be ready. I don't have problem. Okay. That is it. Let me give opportunity to Ebenezer.
Sir, please, I wanted to suggest if it will work Sunday or Saturday. Lectures are not so intensive like that. If we can have the IA on either Saturday or Sunday, the weekends.
Are you sure? Okay. That, like I said, I'll discount the classroom. Yes, Peter.
Okay, sir. Please, I wanted to ask if the AI is going to be on only the ones you've treated with us or what you've done on anatomy so far.
No, just my part.
Okay, thank you.
The neuro science.
Okay.
LC. LC. Abankwa.
Hello, sir. Good morning.
Good morning.
Please, I wanted to suggest that you kindly put the recording on the pages for the course reps to give to us so that those who couldn't join could maybe just listen to the audio and be able to do the I.
Okay.
Thank you.
Okay, no problem. All right. So I wish you all the best. When you get another time, you let me know so that we'll meet and finish with the Nero. Thank you very much. Enjoy all the enjoyment.